Formation of action potential. To understand the formation of action potential in axon membrane, let's consider that the membrane potential for resting potential is minus 70 mV. The threshold potential is about minus 55 mV, and the peak of action potential is about 50 mV. There are 5 series of events involved. First, resting potential. Second, depolarization. Third, raising pace of action potential. Fourth, falling pace of action potential. And fifth is undershoot. Then the axon membrane returns to resting potential again. The first event is resting potential. In resting potential, membrane is not transmitting impulse. The inner membrane is more negative compared to the outer membrane. The voltage-gated sodium ion channel and voltage-gated potassium ion channels are closed. The second event is depolarization. If stimulus is present, depolarization will occur. The stimulus will trigger some of the voltage-gated sodium ions channels to open. The inflow of sodium ions occurs. The inner membrane is depolarized and become less negative. If depolarization reaches the threshold level, which is minus 55 mV, the action potential is formed. Voltage-gated potassium ion channels remains closed. The third event is the raising pace of action potential. Depolarization triggers more voltage-gated sodium ion channels to open. This will cause more sodium ions to influx into the axon. The inner membranes becomes more positive, which is about 50 mV at peak. Action potential is formed. Voltage-gated potassium ion channels remains closed. Fourth event is falling pace of action potential. Voltage-gated sodium ion channels are closed. Meanwhile, voltage-gated potassium ion channels will be open. Potassium ion outflow from the axon. The inner membrane is repolarized and becomes more negative again. The fifth event is undershoot. Most voltage-gated potassium ion channels are slowly closed, but some are still open. Potassium ions continue to outflow. The inner membrane is in hyperpolarization and becomes too negative, which is more than minus 70 mV. When all voltage-gated potassium ion channels close, the sodium-potassium pump will return the inner membrane to resting potential by pump out 3 sodium ion and pump in 2 potassium ion. The axon membrane is in resting potential again.